Hi everybody, it's Tyler here at Riverbots Middle School, checking in with 23382A, 5th Dimension, coming out of Maryland. Inspired at Worlds last year, congratulations on that. And they built a phenomenal machine that we're gonna be talking about here on Pits and Parts. Take a look at this. I mean, I cannot believe this is a middle school team. This is straight up a V5RC, huge competitor right here. We're gonna be talking about all the different aspects that go in this robot. Of course, from their intake, drivetrain, all the way through their redirect. A lot of great sensors as well too, and so much more to learn about this team coming up here on Pits and Parts. Evan, let's talk about the intake on this robot here. This is such a great, awesomely built machine on here. Talking about what your intake is comprised of.
So our intake, it uses 5 flex wheels right here, powered by a motor here, 600 RPM with a chain drive, a 1-to-1 ratio. So the output speed is 600 RPM. We have a ramp here, which has 2 pieces like this. And the reason why we do that is because it makes less surface area than if we do a one solid piece. And our intake, when we drive into it like this, the ramp lifts it up slightly, which engages with the wheels, and we can start intaking like that. And then after the intake goes in, it gets passed on to our conveyor belt stage, which is shared on the same axle as this, which is shared on the same axle here, and it's directly powered by a 600 RPM motor down here too, and it just grabs it into the ring and scoops it up.
I like, by the way, on the front of your robot, you added in these extra supports here, right? Because it gives you that extra reach, essentially. A lot of touch and own it going on, too. So great thinking behind all that also. So let's talk about your drivetrain here and a bit more of what that's comprised of. Michael, walk me through what's comprised in your drive.
Yeah, so we have a 6-motor, 8-wheel drive. The motors are 600 RPM with blue cartridges, geared down to 450 RPM output speed. It's really fast, really reliable. It helps us move around the field really quickly.
So when you were looking at it from a design perspective, what made you want to go with this motor? Like when you were thinking about strategy in the game, you're like, this is exactly what we need, sort of thing?
Yeah, we wanted to be a really fast robot because this year the field's really open. So we want to go from side to side really quickly to get the corners and everything. We also have traction wheels here to help us grip better when defending the corners, and pretty much, yeah.
Yeah, you got the Omni wheels in front, great maneuverability overall on the field. Chloe, let's talk about your redirect arm now. We talked about the intake coming through. I watched your redirect, really cool thing how it pops in, so walk me through how all that works and maybe any feature changes you want to make to that also.
Okay, so this is our redirect, and essentially what happens is after we intake the ring and put it onto the conveyor belt, we're going to, reverse our conveyor belt so that the ring will go into this redirect and into the claw, and then we can raise the arm to score on the wall sticks. It's powered by 2 pneumatic pistons right here, and then we also, that's how we score on the mobile goals.
And how about for the future? What kind of changes do you really want to make to maybe get a little more efficiency out of this?
So in the future, we want to change our redirect to possibly a Lady Brown because we figured that it's a lot faster as it can transfer from the conveyor belt into the Lady Brown a lot faster. And right now, the redirect is also kind of slow and ineffective. And another possibility would also be a fish mech.
Chloe on here, let's spin the robot around and take a look. I really like what you're doing on this clamp here, by the way, too. Really neat for that, and the auto line that goes into that. It's a little, actually, I think one of the more unique ones I've seen for that altogether. So walk me through how it works.
So our robot is a 2 pneumatic single acting clamp, and it has rubber bands to pull it back. And we noticed that we would always clamp at a bad angle, so we added this auto align, which will spin the goal if it comes in, so we can clamp it at a better angle.
And for you, looking at future plans, do you think your team's going to stick with this overall? Has it been working out for you?
Yeah, it's been working pretty well and pretty consistently, so we probably are going to stick with this for the rest of the year.
I mean, I watch you on the field. You just have so much control of the mobile goals. I think that's such an important thing to have in this game, so great job putting that all together. Max, let's talk about the joinker on your robot. I think you called it the cheese grater or something else like that.
We
That
have like
cheese
we have
wedge,
a
awesome.
doink.
So talk to me more about that, and then maybe a couple of the aesthetic choices on your robot too.
All right, so we have a doinker, but we call it a cheese wedge because it's funny. And then like we can use it to sweep the corner. Like we sweep the corner to get the rings out so we can put the goal in. But another unique feature about this is that we can drive up to it and steal opponent goals with it. So it's like it's kind of like a goal clamp on the front basically. And another important part of our robot is the Robosaurus. It makes us 5 times faster and makes us like 10 times more consistent and stuff. It's like really good.
So would you recommend other teams implement this 5 times faster Robosaurus on their robot?
Yes.
So really cool with that. And then I want to ask you from match strategy wise on the goal rush on that. Have you so far used that mechanism as a goal rush so far?
Because like on one of the sides there's like a goal in the middle. So then some teams use it to score on it. So then we can just drive up to it and then steal it. So then it messes up their auton kind of.
Awesome. So yeah, great strategy that goes into that. Let's talk about sensors here. Elvin, Anna, and Katya are going to be talking more about that. So walk me through the different sensors on your robot.
So we have a bunch of sensors on our robot, but I'll be talking about the back 2 sensors. So like we have a AI vision sensor and a distance sensor in the back of our robot. So a quick overview of how it works is that the AI vision sensor takes a snapshot of what it sees, and then it determines if the mobile goal is on its left or right. And then the distance sensor, like when the robot's turning towards the goal, the distance sensor keeps scanning the distance. And then if the distance suddenly changes, we know there's a mobile goal in front of the robot, because like if it's here and then it's turning and then like the distance suddenly changes to like this one to this one, it can detect the sudden change in distance, and then it'll clamp the mobile goal.
How are you actually doing your autonomous programming? Can you walk me through that a little bit?
Oh, so on one side, we score the Alliance wall stick with the arm and the redirect mechanism first, and then we get the mobile goal in the middle using these 2 sensor pairs, and then we score 3 rings on that because we get the 2 rings in the middle and the 1 ring on the side, and then we touch the ladder so we can get the AWP by ourselves. Well, in normal events, not in signatures.
Anna, what other sensors are you using on your robot?
We use the inertial sensor for our rotational position. It is a 3-axis. It's right here. It's 3-axis gyroscope and 3-axis accelerator. And we use the turn to heading function that helps us like our rotational, that tells us the rotational position. We also use gyro PID for more controlled rotations.
We also have 2 sensors that are right here, the limit switch and the optical sensor. So when the ring is intaked, it'll lift up this little tray, which will release this limit switch and send a signal to the optical sensor to take a snapshot of what it's seeing. And if it's the correct colored ring, then it's going to put it on the goal. And if it's not the correct colored ring, then it's gonna unclamp the goal and shoot it off.
Well, Fifth Dimension, congratulations on a phenomenal machine and your continued amazing performance. As we're filming this, 3-0 so far this event, so we can't wait to see how you do, and we really hope that we get a chance to see you back at Worlds again, so good luck the rest of the way.
Add a Robosaurus to your robot.